Hey, how you doing? Mr. H here. We are going to chat today about power functions and function operations. Last time we got together, we chatted a little bit about adding, subtracting, and multiplying. And so now we're going to still see that. We're going to see a different way of saying it, though. So, like, instead of where it says addition here, instead of me just saying, hey, 2x plus 3x plus 1, simplify, we're going to have some different notations. So notice f of x is really 2x. And g of x is 3x plus 1. It's still the same thing. I'm still looking for the like terms that I have. 2x and 3x is 5x. That is my only constant term. And I could label this as a new function. By taking f of x and g of x and putting them together, I get h of x. It's all labels. That's all it really is. This is still my answer, just like it was before. It's just I have a different way of seeing it. You may see that in some of the summatives that we do. Subtraction, same thing. Take my f of x, watch for which one you're being given at any particular time, minus, now this is where I got to stress something, g of x. You can't just put 3x plus 1 here, and I'm going to show you why. I'm going to get my sticky note out here. So if I would have had just 2x minus 3x plus 1, check out what happens. I go to combine my like terms. Okay, that's nothing different. 2 minus 3 is negative 1. And then I just write plus 1. But by putting the parentheses, and I need them because I'm subtracting all of g of x, not just the 3x part. What's going to be different? This is. Okay? That's a big deal. Because now, I'm still going to get the negative 1x, but it's negative 1x minus 1, not plus 1. And we all know how math works. Subtracting 1 and adding 1 are two totally different things. So watch out, and when you're especially putting in like a binomial, a trinomial, anything you see with a plus or minus, make sure that you put the parentheses in. And then multiplication, 2x times 3x plus 1. Well, I knew on this one I'd have to use parentheses. Now remember our exponent rules. When we multiply the coefficients. We add the exponents when we're multiplying. 1 times 2 is 2x. No other x's, though, to deal with. So I leave it. Now, could I combine those? Like 8x to the third? No. Because, again, here you've got to watch it a little bit and say, oh, yeah, I can't really... that's x to the squared, that's x. I can't do that. So, nope, we can't do that. And then division is our interesting one here. So, 2x over 3x plus 1. Another important reason for the parentheses. Why? Anything in parentheses, the only way it can cancel out is if I can take all of it and cancel. Like here, I can't say, oh, x is canceled. They're bonded together. Okay? Unless there's an x in all three parts, over here too, I can't do that, and I can't here. So as far as the actual division goes, that's all I can do. But you're like, why does it say domain restriction? Okay? What's one thing we can't do when we're dividing? I'll give you a hint. What number can't we divide by? 0. You never can't divide by 0. So I need to make sure, okay, that my denominator doesn't equal 0. So I need to make sure that 3x plus 1 never equals 0. So I got to do a little bit of math here, just a little bit. So I'll minus my 1 over and divide by 3. Okay, so my domain restriction is x can't be negative 1/3. Okay, there's a lot of different ways you can write this, and so I'm going to try and prepare you for a few of them here. This is one of them. Another one would be with our domain, since every other number works, you could write that everything from negative infinity to negative 1/3, okay, would be okay. And then everything from negative 1/3 to infinity. What this would basically say is every single number except negative 1/3 is okay. So you may see it written either way. You never can guarantee, depending on what book you're looking at, what app, what, quizzes, Delta Math, how they're going to want it written. So I just want you prepared for any of them. And keep these handy because you can always use them whenever you're doing any of those websites. Okay. The last kind of piece of this that drives people crazy, but we're going to fix it up so it's better. It's called a composition of functions, which means you're literally plugging one function into another. You're substituting one function into the other. And so they can be written several ways, okay? F of g of 2 or f of g of 2. It looks like fog. So what does it mean? Here's what it means. Depending on how we're looking at it, I'll show you both ways, but again, it's not going to change the way we do it mathematically. What I'm going to do first is I'm going to plug 2 into g. Okay, so plug 2 into the g function. Okay, and that's true even if I'm doing it here, because g is the first letter that shows up. So here's my g function. So 2 times my x value, okay, is 2 minus 1. Whatever number is in the parentheses is the number you're substituting, you're plugging in. So I'm plugging it into the g function. So 2 times 2 is 4 minus 1 equals 3. Okay, that's the first step. That takes care of this piece. So now what does that mean? What that means now is that I'm trying to find f of 3. In other words, we're going to plug the answer from part 1 into our f function. So whatever answer I got here at the start, we're going to plug that into the next piece. So the answer I get in the first part is important because if I screwed up the first part, well, now the whole thing is screwed up. So find f of 3. So here's my f function. So 3 times 3 equals 9. And that's my answer. That would equal f of g of 2. Ooh. So it's like doing 2 problems in one. But you move from from right to left. You work your way backwards, no matter which way it's written. And really the only thing that we've got to be careful with on these is making sure we're paying attention to the order the problem's given to us in. So like here, job number 1, 3 goes into F. That's my first job. So here's my F function. Like, dang, Hardy, 3's showing up a lot for that. It is. So f of 3 equals 9. But that's not the answer. That's only the first part. Second part now means we take that answer, 9, and we plug it into the next function that's mentioned, in this case, g. Here's my g of x. To whatever's in the parentheses goes in for x. 18 minus 1 is 17, and that would be g of f of 3. Or you could write it this way too. Okay? So just keep working your way backwards. Number into function, answer into next function. And that's all we're doing. Now, This last one can get a little weird though. You're like, wait, I can plug something into itself? Yeah. Same way, not changing a thing. First step, plug -2 into f. Now hopefully, well, I mean, you've got your paper somewhere in front of you here. So f is 3 times x, so 3 times what's in the parentheses, the -2. So there's -6. And then that answer is what we're plugging into the last part, which in this case is f again. You're like, so I don't have to use both functions every time? Not if it's not asked for, nope. So same function, 3x, except this time I'm replacing the x with a -6. So I just got to pay attention to what the function notation is to see which function, which expression, not equation, that I'm plugging into. Nothing too bad. All right. Let's see what else we got rolling here on the back. Okay, a little more practice. Again, I got to pay attention to really basic things here so I don't get fooled. Like, not every function is going to be composition. Okay, here. I got f of x and g of x again, but that's not an open circle. Okay, that's multiply. So you're like, okay, what does that mean? That means I'm going to take f of 5 and I'm going to multiply it times g of 5. In other words, I'm going to take f of 5, plug the 5 in there for x. 15 plus 2 is 17. And then I'm going to plug in 5 for g. And again, when you're doing these on your own, if you look at it and you can do some of these parts in your head, that's fine. I just on a lesson want you to be able to see what it is that we're doing. So you can look back later and go, where'd you get that from? 5 times 5 minus 4. Because again, I'm just plugging into the g function. 25 minus 4 is 21. And I got to multiply those together, because that's what it says, multiply. And this would be f times g of 5. Now, could I, if I wanted to, multiply these together and then plug the number in? Yeah, but that's a lot of work. I wouldn't go down that road. Wouldn't do it. Okay, division. F of g. So f of x divided by g of x. Keep the parentheses. Because why? I don't want you canceling those x's. Again, they're bonded. Plus or minus is a strong bond. It doesn't separate unless things are identical. And all this stuff, there's nothing I can take out of all 4 of those. So we can't do that. So as far as finding it, that's it. But we're going to star here. Whenever there is division, you need to take note that there's probably going to be a domain restriction. The only time there wouldn't be is if this is just a number. But there's an x there. So I need to make sure that 5x minus 4 doesn't equal 0. This only happens on division. Go ahead and solve that. Okay, and for my purposes, again, x isn't equal to 4/5. That's fine. That is your domain restriction. Again, if you're asked in some big, long interval notation to do it, just remember, it's negative infinity to that value, parenthesis, because we don't want the number being included, because that's the restriction. And then we just do it again to positive infinity. Either way works. We just got to be flexible for whatever the particular, program we're using is going to ask. But only on division. Okay, multiplication. Ooh, multiplication with a twist. Okay. So we need f of 4 times g of 4. Now, I noticed this first one, f of 4, has absolute value with it. Now remember, what do we know about absolute value? The answer that comes out is always positive. So 8 minus 1 is 7. Even if that would have been a negative value, let's say it would have been negative 7, when it comes out it's positive. So I've got to make sure I remember that part with my absolute value if that pops up again. G of 4, again, just pop it in there, always using parentheses with our plugged in values. 20 minus 4 is 16, and we're being asked to multiply them together. Really should be doing this in my head, but you know. F times G of 4. So again, be careful. Little pin dot is multiply. Circle there, like it's the word fog, is composition, like we were doing on the front. Details. One composition to finish them up. First step, negative 2 into G. So there's my G function. 5 times negative 2 is negative 10. Minus 4 is negative 14. And then we're taking that answer and plugging it into F. It's just like doing 2 steps, just 2 different equations this time. Oh, be careful. Absolute value. We're going to go ahead and draw the extra step in here just to remind ourselves of some stuff. 2 times negative 14 is negative 28 minus 1 is negative 29, but the absolute value of a negative, because its distance is, oopsie, mislabeled my answer. I'm going to cheat and come to this side. Okay. So we still got to have our algebra and our number sense details here as we work through these. So as we're doing this week, okay, as you get done and you're working into the practice, you'll notice I've got this listed right in the Google Classroom for today, but if you look at your tracker, it's not listed until tomorrow. So maybe you do a little bit today and a little bit tomorrow. Maybe, like I've said on other assignments with this, maybe you just do the evens and then check your answer, and then if you need to, go back and do some odds. But just kind of keep working it in. Maybe while it's fresh in your mind, you do it. I would probably do that myself. So that will wrap us up here for our power functions lesson. Next time we'll be checking a look at graphing some of these, so stay tuned.